Okay, today is Chapter 3, Section 2, Solving Systems of Linear Equations by the Substitution Method. I'm not sure if it's going to fit. Well, we'll just cut it in half. How about that? Alright, so this seems like a lot to unpack here, alright? Alright, so let's just start. Here we go. For the record, not that you asked or that you care, but I'm going to tell you anyways. Excuse me. I used to when I did first start teaching. I used to teach with notes, notes, and then I would lecture and all that stuff. But at some point, I remembered that. So I used to be a horrible student, right? I'm not accusing any of you of thinking as dumb as I did, but I assume there's at least some of you. I thought that you should be able to learn everything you should learn in the classroom. Okay, it was very short-sighted of me until I got a chemistry professor that was just awful. Okay, this chemistry professor was so awful that I had to go home and actually open my textbook and teach myself. Well, I became a genius at chemistry because I went home, I opened the textbook, and I learned for myself. I didn't depend on this professor to teach me. All right. Now, that's not what I'm trying to do for you. I want to teach you, but I also want you to learn on your own. But I like to teach from the textbook like this because it really shows you where I'm getting this information and what I'm talking from, and it really to me it kind of really drives home the point that guys, use your textbook, right? It's loaded with information, and you can't possibly expect to learn everything about a subject by just hearing me speak. Right? So that's why I teach the way I do now. Like obviously COVID is a thing, but even before COVID, this is how I instructed. So there you go. Moving on, the substitution method. All right, so graphing a system of equations is one method to find the solution. That graphing was section 3.1, but we're not covering that. I don't think. I don't think we cover it in this course, but that's because it's super duper easy, right? We can't be having super duper easy stuff now, can we? Right. So it reads, however, sometimes it is difficult to determine a solution using this method because of limitations in the accuracy of the graph. This is particularly true when the coordinate of a solution are not integer values. Okay. So what this is saying is, what if you have a point 3/17 and negative 23/9, right? Looking at a graph, you can't really tell that you're passing through the point 3/17, right? You might be like, okay, I'm like a fifth of the way to the next point, but I mean, it's not an exact science, right? So, in this section, we will present the first two algebraic methods to solve a system of equations. The first is going to be called the substitution method. This technique is particularly important because it can be used to solve more advanced problems, including nonlinear systems of equations. And when we say more advanced problems, we're talking about calculus problems, right? Things that are a lot more advanced, but you use this method in those courses. The first step in the substitution process is to isolate one of the variables from one of the equations, right? So, let's see, okay, good. So it says consider the system. We have x plus y is equal to 16 and x minus y is equal to 4. Okay, we need to figure out what x and y is. What solves that, right? So starting over, looking over here, like this, it's just a continuation. Solving the first equation for x yields x is equal to 16 minus y. Then because x is equal to 16 minus y, the expression 16 minus y may replace the x in the second equation. This leaves the second equation in terms of y only. So the first equation we solve for x. So x is equal to 16 minus y. So what we're going to do is substitute that x value in for x in the second equation. Okay, so the second equation will become 16 minus y is equal, or I'm sorry, 16 minus y is equal to 4. And then when we do the arithmetic there, you get y is equal to 6. All right. Well, now you have that y is equal to 6. You can take that 6 and then put it back into the first equation and then solve for x, right? You substitute the 6 back into this equation up here, right? You get x plus 6 equal to 16. You subtract 6 on both sides, you get x equal to 10. And that's what you get here, okay? And these are the steps, 1 through 5. You can use those steps, all right? There's nothing wrong with it, but to me, I mean, we're going to come across these step-by-step ways to solve solutions a lot in this course. Okay, it's going to pop up a lot, right? I'm not going to follow them per se, but I will follow them. It's kind of like making a peanut butter and jelly sandwich, right? When you make a sandwich, you don't go step 1, step 2, step 3. You're like, okay, I need this, I need this, I need this, and then you completed it. So that's mainly the process I'm going by. But I will cover it. But I don't necessarily follow it. I don't go step 1, do this, step 2, do this. But step 1, we do need to isolate one of the variables from one of the equations, okay? And you're generally going to know which one that you want to isolate, and we'll see it in these problems that when we get there, and then I'll explain it better then, okay? Step 2, we're going to substitute the quantity found in step 1 into the other equation. Okay, that's basically what we did here. So step 1 was isolating the x. Step 2 is me substituting this into the second equation. Step 3, solve the resulting equation. Okay, which we got was y is equal to 3. So let's actually denote this, right? So this is going to be step 1. Step 2 is this substitution there. Step 3 is we solve, right? Step 4 is we substitute it back, and then 5 is you substitute to make sure it's true. Okay, so hey, that worked out pretty well actually. Good job. All right, so let's actually go ahead and do an example. Okay. All right, so let's read. Solve the system by using the substitution method. Okay, so let's go ahead and rewrite this problem. Okay, so I said that you're pretty much going to know which variable you're going to isolate, and here's why. If I wanted to isolate the x in this equation, I would have to add 2y to both sides, and then I would have to divide by 3. Okay. If I wanted to isolate this y, I would have to subtract 3x from both sides, and then divide by -2. Okay. Kind of same thing here. I would have to subtract y from both sides and then divide by 6. Whereas this y right here is all by its lonesome, right? Where the other steps involve 2 steps, right? All I have to do here is just simply subtract 6x from both sides. So that's what I'm going to do. Okay. So we're going to take this equation and we're just going to change it to y is equal to -6x plus 6. Let's do it again. Plus 6. Okay. -6x plus 6. Well, now what we're going to do is we're going to take this y value and substitute it in for this y right here. Okay, and keep in mind the color coordination there. Okay, so what we're going to do is we're going to let's see. I want to make this flow. So what we'll do is we'll put it in blue, I guess. Okay, we'll do this. We'll just make it flow. So we're going to say 3x minus 2y, but y here is going to be a -6x plus 6. That's equal to -7. Positive 7. -7. Okay, we're going to do the arithmetic here now. Okay, so we're going to have a 3x, and then we're going to distribute this -2x into both of these. So we're going to have looks like it's going to be a positive I said distribute negative 2x. I didn't mean negative 2x. We're going to distribute the negative 2. Sorry. So it's going to be a positive 12x minus 12. That's going to be equal to a negative 7. And again, I feel like y'all can't see these toolbars down here, I don't think, so I'm going to have to move these real quick. All right, and then we solve this. Well, 3x plus 12x, so that's going to be 15x. And then we add 12 to both sides, so we're going to end up with is equal to, we add 12 to both sides, we end up with 5. So therefore we have x is equal to 1/3. Put an arrow here. X is equal to 1/3. Okay. All right. So if x is equal to 1/3, let's go ahead and put 1/3 up here. Let's go ahead and put 1/3 for my x value. Okay, this is just going to be a coordinate point here. All right. Well, how do I get my y value? Well, I substitute my x back into my original y here. So this x is going to go up here to this y. Okay. So, man, really running out of room here. I want to make it flow a lot better than it does. So we're going to try and make this a little bit better. So we're going to say, let's put it in red. Let's rotate this up here. Okay, so we're going to have y is equal to a negative 6, and then we said x was 1/3 plus 6. Okay, well, negative 6 times a 1/3 is going to be a negative 2. Negative 2 plus 6 is going to be a, what did I say? Negative 2. Negative 2 plus 6 is going to be a positive 4. Okay. And so 4 will be my, let's put in green, sorry. 4 will be my y value. Okay, there's lots to unpack here, so let me try and go over that all again one more time. Here's my system of linear equations. Okay, I said it's easier if I find the variable that doesn't have a coefficient in front of it, because all I have to do is subtract 6x from both sides, and that's how I got this over here in the yellow. Okay, well, that's my y value. So what I had to do now is as I plug this y value in for this y right here, and we see that here. We plugged in negative 6x plus 6. Okay, and then we did the arithmetic for that. We did the arithmetic for this. We plugged it in, we distributed all that good stuff, and we ended up with x equal to 1/3. Okay, well, x equals 1/3 is my x value now. So I plug that in for my original y here. Okay, because again, what's in yellow is exactly this. It's just a little rearranged. Okay, so I plug this x equals 1/3, put the 1/3 right here, right, and that's where you see this equation right here. I just plugged the x into that, I did the arithmetic, and I got my y value is equal to 4. Okay. So the x value I got was 1/3, so it's going to go into the x in the x section of a coordinate, and my y value is 4. It's going to go into the y value of the coordinate. Right, and that is the substitution method. Let me move stuff around again so I can have room. Okay, all right, so that's example 1. That was quite long, yes. Example 2. Sometimes you're just given a bone, and this is one of those cases. Okay. So we need to use the substitution method, obviously, but lucky for us, they've already given us the x value for the second one, right? So they've already rearranged it and solved for x. So what I need to do is plug this x in for the x in the original in the top equation rather, and then solve for y. So let's go ahead and begin that process. Oh no, okay. So let's go ahead and begin that process. So we have a negative 3, and we know x is negative 1/3 y plus 2, right? That's going to be plus 4y is equal to 9. Okay, again, just in case you missed it, I'm plugging this x value in for this x. Okay, so notice how this the same thing as that right there. All right, and we're saying x is equal to this, and therefore we're plugging it into the value for x. Okay, well, we got to do the arithmetic here. So we've got a -3 times a -1/3. That's going to be a positive y minus 6 plus 4y is equal to 9. We're going to solve for y. Looks like we can combine the y's to be 5y. We add 6 to both sides. We end up with a 15. So we have y is equal to 3. Okay, y is equal to 3. So now what we have to do is plug this y is equal to 3 into the y for the original x. Okay, so we do that, we have x is equal to a -1/3, and then y, which is 3, plus 2. Okay, this makes it pretty easy, right? Y is so -1/3 times 3. That's just going to be a -1. -1 plus 2 is a 1. So my x point is a 1 and my y point is a 3. Therefore, my solution is 1, 3. Okay, that seems a lot easier. And we have doing rearranging, so that makes that part easier. All right. Okay, so this reads. Let's see what that say. Okay. Well, so this reads. Example 3, solve an inconsistent system. So what is an inconsistent system? Well, let's find out. Okay, well, this looks pretty, again, it's nice and set up kind of like how the previous example was, right? We've already got one equation that's rearranged for us. It's awfully nice of the editor there. So let's go ahead and plug that in. So we have a -2, and then x is 2y minus 4 plus 4y is equal to 6. We have we distribute that -2. We've got a -4y plus 8 plus 4y is equal to 6. All right, the y's combine into, oh no, 0y plus 8 is equal to 6. 8 is equal to 6. Does 8 equal to 6? No, obviously not, right? So that is an inconsistent system. What this tells us is that there is no solution. Put this right here. There is no solution. The system is inconsistent, and therefore the solution set is those two curly braces means the empty set. Like it's empty. There's nothing in there. So that's what an inconsistent system is. Okay, you get to this point and you say, oh, okay, so 8 does not equal to 6. The system is inconsistent. So that's what an inconsistent system is. It's fun to say inconsistent. No, it's not. Stop. Let's quit. All right. And then we have here a system of dependent equations. So what does dependent equations mean? Well, let's solve this and figure it out. Okay. So unfortunately, they don't have it in a nice neat package for us. So let's go ahead and rewrite. We're only going to rewrite the top one essentially. And this is probably what I should have done for that one example was have it rewritten. But the second equation, if I add 3 to both sides, I'll have y is equal to 2x plus 3, right? That's pretty easy. So y is equal to 2x plus 3. So what I'm going to do is I'm going to plug this value in for the y up here. Okay. So by doing that, I'll have a 4x minus 2 times 2x plus 3 is equal to -6. Okay, so I've got 4x, and then I've got minus 4x. Okay, yeah, 4x minus 4x minus 6 is equal to a -6. Well, similar to the previous problem, the 4x's, they're going to cancel, right? So I'm going to have a -6 is equal to a -6. Okay, so this is an example of a dependent equation. So what exactly is a dependent equation? So I don't know if I said it earlier. Oh shoot, I don't know if I did. Okay, Well, yeah, I did. I said there's no solution. That means there's no way. I'm back to example 3. There's no way that you can plug in anything example 3 to make it work. Okay. Example 4. They are the exact same equation. Okay. So because this tells me that it doesn't matter what I plug into one, I can plug into the other and it'll still work. Okay, so what this tells me is they're the exact same line. So let's examine that real quick. Let's take a look at this equation here. Okay, let's go ahead and solve for y here. So we've got a negative 2y is equal to a negative 4x minus 6. So I divide both sides by negative 2y. I've got y is equal to a 2x plus 3. Notice how that is the exact same as that. That's what a dependent equation is. And let's see, we'll put, well, we'll go and put snip this as well. Page. Okay, they are the exact same equations, and therefore they're equivalent. Okay. And I believe that is the end of this section. So lucky for us, yeah, that's the end. That concludes chapter 3, section 2.